Thank you guys for coming. So today we're going to see how OPA and SPIRE, these two awesome open source projects, are going to work together to provide decoupled authentication and authorization. A bit about myself, I'm Ash Narkar. I'm a software engineer at Styra and I'm a core contributor to the Open Policy Agent project. Today I thought I'd just start with an overview of OPA and then we'll go deep into the integration of how SPIRE and OPA work together. So a bit about OPA's community. OPA was founded in 2016 at Styra. We've had multiple users. Netflix is one of the earliest adopters of OPA. And a lot of companies are using OPA for authentication or authorization around RBAC, ABAC, data protection, and so on. And OPA is a CNCF incubating project. We have a healthy Slack and GitHub community. And so let's see what OPA actually is. So OPA is an open source general purpose policy engine. When you use OPA, you are decoupling the policy enforcement from the policy decision making. In this way, your services can offload policy decisions to OPA by executing queries. So for an example, imagine you have a service, and this can be any service. It can be your Kubernetes API server, your Kafka, your Envoy, your Istio, your own custom service, does not matter. So whenever your service gets a request, your service is going to ask OPA whether this request is allowed or not. And this request can contain information like the request path, the method, the user, basically any JSON value. And so OPA is going to evaluate this query based on the policies and data it has loaded and send a decision back to your service where it actually gets enforced. And even the cool thing here is the decision itself is also any JSON value. And so again, what we see here, we are decoupling the policy enforcement from the policy decision-making process. Just few features of OPA. At the core of OPA is a high-level declarative language called as Rego. And so with Rego, what you can do is not just allow, deny, true, false Boolean decisions, but you can do much more than that. You can have collection of values. For example, which users are allowed. For example, what fields is a user allowed to see. So much more than just allow, deny, true, false, yes, no. OPA is written in Go, and you can deploy it as a sidecar or a host level daemon, or you can embed it inside your Go code. So there are multiple deployment models you can use for OPA. OPA is designed to be as lightweight as possible. It does not have any external dependencies for making a policy decision. However, you can extend OPA so that it pulls down policies and data from remote servers and also upload decision logs to remote servers. So it does provide some management APIs which allow you to do that. And lastly, along with the core policy engine, OPA provides a rich set of tooling which you can use to build, debug, and test your policies. OPA has a unit test framework, it has integrations with VS Code, and also a Rego playground, which we will see later. So like I said before, OPA has integrations with multiple projects. This is just a snapshot of some of them. But one thing I want to emphasize here is that you can use any of these integrations out of the box without having to write a single piece of code to enforce custom policies in your cluster. With that, let's go to OPA and SPIRE and let's see how these two awesome open source projects can collaborate on authentication and authorization. So before we jump into that, I want to talk about Envoy. So have you all heard about Envoy? Okay, cool. So as you guys know, Envoy is a proxy and a communication bus, and Envoy has this thing called an external authorization filter, which can call external services to ask whether an incoming request is allowed or not. And so when Envoy gets a request, it's going to ask OPA whether this request is allowed or not. And if the request is not allowed, a 403 gets returned to the client. If it's allowed, the request gets forwarded to the upstream. And so now they're going to use this basic building block in our overall demo. And so what we have here are we're going to have three applications: a web service, a backend service, and a DB service. The web service is what takes incoming calls from the API server, forwards them to the backend service, and which forwards them to the DB service. Each of these services has a co-located running service envoy. For secure communication between these envoy proxies, they are configured to use MTLS communication. And so for that, each of these envoys is going to talk to a SPIRE agent, which is implementing the secret discovery service protocol to provide the certificates that are needed for that TLS communication. The SPIRE agent in itself is going to ask the SPIRE server to provide all these certificates which will be needed in the MTLS communication. So the point here is that the SPIRE server is going to provide unique identities for each of these services by embedding the SPIFFE ID in the TLS certificate, which will then be used by OPA to build the authorization policy around. And so the policy that we are going to demo today is going to say that there is a good path and there is a bad path. A good path flows from the web service to the backend service to the DB service. That's the good path. And if the web service tries to talk directly to the DB service, that's the bad path, and we don't want that to happen. So what I have right now are all the services, all the applications, OPA, SPIRE, the agents, all are running on my machine on top of Docker Compose. And so I'm going to run two calls here. I'm going to run an API call which is going to simulate the good path from the web to the backend to the DB, and hopefully that succeeds. And then I'll run a second API call to simulate the bad path between the web and the DB. Hopefully that fails, and we're going to see why it failed and what the policy that was enforced that made it fail. So I'm just going to run the good path for now, and like you see, it's allowed. It's a 200. It flowed from the web to the backend to the DB service. I promise I have not hard-coded this. This is actually live going on right now. And so now I'm going to simulate the bad path by running another API call. And in this case, I'm getting a 403, which is forbidden because the web service tried to talk directly to the DB service. And so the policy that made this happen looks something like this. So this is called the Rego Playground. The Rego Playground is an online interactive tool you can use to experiment with Rego policies. It's play.openpolicyagent.org. And so the policy that is getting enforced by the DB service essentially has an allow rule which says that if there is a request coming in for the good path, which is for the method get, and it's only been made by the backend server, you will allow that request. Otherwise, you're going to deny that request. And so in this picture, if you look at line 11, OPA is getting the SPIFFE ID from the X forwarded for client header, which was injected by Envoy, and the actual value for that URI was got by Envoy from the SPIRE agent, which is running on that host. And so you guys can try this demo out, not for just this one use case. There is another use case around using the same infrastructure with SPIRE, OPA, and Envoy on this blog out here on the OPA website. So try that out. And so finally, what I want to say that we have OPA, we have Envoy, we have SPIRE, which are two awesome open source projects, and we just saw how we can do decoupled authentication authorization. And so the idea here is that you can use the secure identity framework provided by SPIRE to take those SPIFFE IDs, inject them into your TLS certificates, and then you have OPA, which can leverage those to help you build out your authorization policy for enforcing custom fine-grained security policies in your cluster. So that's how we hope this integration works and gets used by you guys. If you guys want to learn more about OPA, stop by the Styra booth on S75. If you guys want one of these really awesome limited edition OPA shirts, please stop by the booth. Check out the OPA project on openpolicyagent.org. Check out the SPIRE project. We are on Slack if you guys have any questions. And again, thank you for your time and thanks for stopping by.